Colligative properties. Co means together, ligate means binding. There will be binding between solute and solvent particle in a solution. So because of that, what will happen to certain properties? The first property what we are going to discuss here is relative lowering of vapor pressure. Say for example, you take water. Okay, so water can undergo vaporization and its vapor will be present here above the water level. So the pressure exerted by this vapor is called vapor pressure. This vapor pressure is given by the symbol P0. Here we will be using the word pure component, vapor pressure of pure component. Pure here means single component, only water alone is there. Now to this water we are going to add a solute like sugar or salt. The solute should be non-volatile in nature. Non-volatile, it shouldn't get evaporated. Right? Okay, so once the solution is prepared, the vapor pressure of solution is given by the symbol PS. This here also water alone can undergo vaporization. The pressure exerted by this vapor is given as PS. Now comparing P0 and PS, which will be more? P0 will be more, PS will be less. Why? Because in solution both solute and solvent molecules are there. Out of these two, only solvent alone can undergo vaporization. Solute cannot undergo vaporization. But what solute molecule will do? Solute will act as a hurdle that will not allow the molecule, solvent molecule to undergo vaporization in the faster rate. Okay, once the solution is formed, the solute which is present, the solvent which is present below the solute cannot undergo easily vaporization because the solute cannot undergo vaporization, so it cannot allow the solvent molecule to undergo vaporization in the faster rate. There will be bond formation between solute and solvent, ligate binding between solute and solvent. So what will happen as the result? The vaporization tendency of solvent will get reduced. So less vapor in the sense vapor pressure is also less. So always vapor pressure of solution is less than that of vapor pressure of pure water. Understood? Now the difference between the two is taken as delta P. Delta is the difference between the vapor pressure of solvent and solution. Since it is more, we will write it as P0 minus PS. Now, so lowering of vapor pressure in the sense, by the addition of solute to the solvent, pure solvent, the vapor pressure is getting decreased. So that is why we do call this as lowering of vapor pressure. Now, relative lowering of vapor pressure. Relative means comparative study. So we are going to compare the lowering of vapor pressure with that of pure solvent. So pure solvent vapor pressure is P0. So it is comparative study. So both the sides you divide it by P0. So this is lowering of vapor pressure. Delta P is lowering of vapor pressure. Delta P by P0 is relative lowering of vapor pressure. The entire term is relative lowering of vapor pressure. Now, this vapor pressure of pure solution is nothing but vapor pressure of water or solvent in solution. Because in solution, the solute molecule cannot undergo vaporization. Solvent alone can undergo vaporization. So, vapor pressure is a technical term applicable only for the vapor. Okay, so solvent alone can undergo vaporization. So, the vapor pressure is purely due to water. But P1 is the vapor pressure of solvent when it is in the solution form. Whereas P0 is the vapor pressure of solvent when it is in the pure form, single component. So difference is there. So here PS is replaced by P1. So we will write delta P by P0 is equal to P0 minus P1 by P0. According to Raoult's law, P1 is directly proportional to X1. P1 is nothing but vapor pressure of solvent in the solution. It is directly proportional to mole fraction of solvent in the solution. So here more number of moles of solvent is there, more its vapor will be there. More its vapor in the sense more vapor pressure. So this is Raoult's law. So vapor pressure is directly proportional to mole fraction. In order to remove the proportionality sign, we will introduce a constant, that is P0. P0 is nothing but vapor pressure of pure solvent. So we will replace, here P1 is replaced by this term. So your equation will become delta P by P0 is equal to P0 minus P0 P1 is replaced by P0 into x1 whole divided by P0. So here you can take it P0 as common term. So 1 minus x1. So both the terms you have P0 whole divided by P0. P0 and P0 will get cancelled. So delta P by P0 is equal to 1 minus x1. But we have learned that mole fraction of both the components, first component that is solvent plus mole fraction of solute is equal to 1. Mole fraction of solution is found to be 1. So we can write is equal to 1. So we can write here 1 minus x1, that is x2 is equal to 1 minus x1. So 1 minus x1 will be replaced by x2. So what we have arrived is the relative lowering of vapor pressure is equal to x2, that is x is mole fraction of the next component. Here the next component is solute, okay, solute.